I asked and he told me that you wanted to see air tool repair videos, so today is the first in the series because we have a number of tools coming in on the bench right now. The first we're going to start with is an Ingersoll-Rand 2235TiMAX half-inch drive air impact. The problem that was reported was that one of the hammer case screws has fallen out, and as a result, there's an air gap between the hammer case and the body of the tool where a gasket sits. The gaskets become misshapen, and as a result, there's air that escapes through the opening and the tool has low power. So we're going to disassemble it entirely, see if that is in fact the cause of the problem, and see if we can uncover any additional issues. There's 4 screws that go through the body and thread into the nose cone, and it keeps the entire assembly tight, and separating it is this gasket in between. One of the screws fell out and is missing. So as a result, what happens is you have uneven pressure on the gasket and you're going to have a gap where the screw is missing. So as a result, the tool leaks air, and when it leaks air, of course, you're not going to have the power that you require because you're losing pressure that would normally be applied against the motor. Instead, it leaks out through the side here. So if that's all that's wrong with this, it's going to be an extremely simple fix. All we'd have to do is order a screw and a gasket for it, and then we'd be back up and running. But in an effort to do a thorough diagnosis, so I want to make sure that everything's accounted for, we're going to disassemble this and clean it too, because we're going to charge the customer an hour of bench time on this, and I want to make sure that I do something to earn my money. And it's always a good idea to clean and lubricate these guys because they don't generally get that in their life cycle. So we're going to help prolong the life of this tool by giving it a thorough once-over, making sure everything works, cleaning out the old grease and lubricant, re-lubricating it, and then getting whatever replacement parts we need. So first step, a T20 Torx screw is what we're going to need to remove these screws. And you got to be careful because the whole front assembly comes off as one unit. And you can take a look in there and see there's a lot of old grease in there. And we're going to take this all apart and give it a good cleaning. The screws drop out of the back pretty easily. These all go in this container here, and I'm going to use this as my parts cleaner. So we'll put our solvent in there and clean everything. And then what's left in here is the spline drive for the hammer assembly, and it's all around a sealed bearing that's in there. And then this is the front of the motor assembly. We're going to take all this stuff apart and go over it, but you know, just looking at it initially, it doesn't look like there's any problems. But again, a lot of times these things never get cleaned up, so we're going to start it fresh with new lubricant and look over everything. This guy here is the gasket. That's going to get replaced. We're not even going to attempt to reuse it. And as I look at the rest of the housing, everything in there looks okay. Doesn't look like there's any damage on it. So as we disassemble things further and take a close look at everything, we'll see if there's anything else that needs to be addressed. So the easiest part of this is removing the hammer assembly and anvil from the nose cone. That just drops out. And then you have the cone, and there's usually a whole bunch of grease that gets built up inside there, and sure enough, there is. That's going to go in our parts washer. And now what you're left with is the anvil, which pulls out of the hammer assembly. Just got to give it a couple of, work it free there, because it's kind of a funny, it's got an irregular shape to it. And that pulls out. This is your anvil. And here's your hammer assembly, and you have 2 hammers in there, and they're around this little hammer cage that holds everything together. Those just fall right out because there are 2 pins. They always drop out on their own. These 2 pins here hold the hammers in their cage, but they always fall out because there's nothing to actually keep the pins in there. So those go in, those go in. Wipe my hands. Why aren't you wearing gloves, Lindsay? I don't know, because I don't generally. I don't like the feel of them. so I don't usually wear gloves. The motor assembly just pops out. It's held, well, on the back is also a selector switch, but this whole thing comes out as one assembly, just like that. And then the body has a few things in it. There's a gasket in the back there. That red gasket with the two rectangular type of holes. And this guy is the selector for the forward and reverse operation. As you push your forward and reverse switches and back, it turns that selector. See that? And that just determines which side of the motor the air gets ported to. So with the switch in one position, it ports the air up through one side of the motor and spins it in one direction. You push the button and turn that selector, it ports the air up the opposite side of the motor to spin it in the opposite direction. Very simple mechanism. In the handle here is a throttle body, and there's a valve that the trigger stem attaches to actuate the valve. We're not going to go that deep into this. We don't have to disassemble it to that degree. Assuming there's not a problem with it. Once we have everything tested out, we'll check it, but I'm confident based on what the customer told me that this all works fine. So we're really just going to look at cleaning up the components that we took out. Going over, the motor has this piece in front, this ring here, that just pulls off like that. And there's the bearing sits inside there and then exposes the motor. They call it, technically this is called the rotor. Little spline drive grabs the front of the hammer assembly. And then these 7 tan-colored things are the motor vanes. And they are what's responsible for grabbing the air that gets ported through either side of the motor and then spins it. And as the motor turns, it's kind of hard to see, but the vanes slide in and out of their slots on the motor. And as you select the selector switch, it pushes air up one side to spin the motor this way, or it pushes air up the other side to spin it the opposite way. And these vanes can wear over time, and sometimes when people just say that their impact tool is lacking power, then all they have to do is rebuild certain parts of it. Usually the rotor's not a wear piece at all. That's a pretty solid hunk of metal. The parts that usually wear these plastic vanes, because there's friction there, and the vanes ride against the inside of the motor housing, and sometimes they'll wear down over time, especially if you don't keep it well lubricated. But we're going to take those out and see about any wear on the vanes. We'll clean them up anyway. And they're all held in back with a piece underneath the selector switch. So we got to pop the selector switch off. And these vanes, they fall out all the time because there's enough of a gap in the top of the housing there where if you just turn this, you can just pull the vanes right out. And it's important to note when you do this that they come out and go in a certain way, because there is a specific shape to this. I hope you can see it. I don't know. There. See that angle that's cut right in there? If you look on the back of it, it's different. It's just got one slope to it, and that's got a cut in it. This goes toward the front of the motor housing. So if you take these apart yourself, make sure you put them back correctly. That notch goes toward the front of the motor housing. This goes toward the rear.
Well, you probably could just get one of them in and get the other one real close.
All 7 vanes are taken out. Let's pull the selector off the back. That's pretty gunky. It's got an O-ring in there. We'll clean everything up. In the rear of the motor housing is a snap ring right there, and that holds the motor in the housing. So we're just going to take that snap ring out, and then the motor will just drop out. This is an external snap ring because it goes around the outside of the thing that it holds in there, so it has to be spread to be removed as opposed to an internal ring which goes along the inside surface of something that it holds in place. The internal ones need to be compressed to be removed. So our snap ring pliers are either or. There's just a pivot piece in the middle there that you unscrew, and then you can move each half of the snap ring pliers to be either an internal set or an external set. I suggest that if you're buying snap ring pliers, that you buy a set that has that feature. This is just a little screw fitting in there, but there are ones that have a quick connect, quarter turn little thing. Those tend to be more expensive. The ones from Lang are outstanding. We also have the ones from K-Tool, which cost a little bit less money, but the Lang ones are USA made, which I really like. The K-Tool ones that we have are not, but there's also, there's like a million different brands of snap ring pliers. Anyway, so this guy here, we're just going to go spread this ring. Spread the ring, it just pops off once you get it wide enough. That goes in our parts washer. And now that the ring is removed from the back, the motor just pulls right out. Boom, done. And it looks like there's some scoring on there. So we'll see if that cleans up. Certainly that's going to affect how easily this turns in there. So that's no doubt also robbing power because it's robbing efficiency out of the motor. I can feel that there's some buildup on there. So there's definitely some substances on there. I don't know if that's maybe just burned lubricant. This doesn't seem to be lubricated terribly well. You want to normally see a nice coating of oil on this. It says right on the tool to oil daily. So after you use it, a couple of drops of oil, pull the trigger a couple of times just to work the oil through, are going to keep everything well lubricated and prevent that kind of thing from happening. You can see it on that one pretty good. So. Everything goes in the parts washer / Tupperware container. I would love to own a small parts washer. That'd be fun. I'd wash everything in there. Give the cats a bath. No, I wouldn't. Not a parts washer. Stop that. I'll just go through each piece, get off all the heavy buildup first, just using a paper towel, and then we'll go through there more finely with a pick and remove some more, and then finally we'll put some solvent through it with a brush. Just going to use a nylon brush with some brake clean to go over everything. Something to note about this bearing is this is a sealed unit, so I can't get any lubrication in there, so nothing's going to come out. These are also pressed in there. They're kind of a pain to remove, so I'm going to leave this in here. So this bearing, which sits right in here, is going to stay. If I were to remove that, I'd need... it's tough to remove because there's no way to push on it from the opposite side. So it's tough to get those out. It's going to stay in there. It's really a no maintenance kind of item. So as long as we make sure it's all cleaned up in there, we should be fine. All right, now that we went over the motor a little bit, it gives us a chance to look at all that scoring on there. It's definitely a problem with the surface of the motor, and that's going to add friction. You can feel a distinct change in texture. So I don't think we're going to need to replace the rotor because the rotor is probably the most expensive piece of this. So we're going to save some cost first. See if we can get that stuff off there with like a steel wool, or maybe just polish it up on a wheel. But one way or the other, I'm pretty sure it's going to come off. It's either rust. It looks more like rust now that we've had a chance to look at it than it does look like there's any damage. But we also want to see if there's any pitting to the rotor surface. And this is why you oil your air tools, kids, because you don't want rust to build up. What happens is when air is compressed through a compressor and then sent through the lines of your shop, then moisture is extracted from the air and gets sent into your tools unless you have line dryers and water separators on your line. A lot of shops don't. So what happens is you get rust in your tools. That's why they tell you to oil the tool after every use, not just for lubrication, but because oil displaces water. And when the water settles in your motor, this is what happens to it. Here is every part to the impact completely disassembled and degreased. It hasn't been thoroughly cleaned yet. We're going to do that later, but at least want to show you all the parts. So you have the body, motor housing, the motor, the faceplate for the motor with the bearing in it, selector switch, your 7 vanes, 2 hammers, hammer cage, your pins for the hammers, anvil, body screws to cone, and of course, the gasket. So the things that we're going to have to do are get an additional screw. We need 4 of them. We're going to have to replace the gasket, and we're going to clean up the face of the motor. Once we do that, everything should be tip-top because there doesn't appear to be any damage to anything, but we're going to go look for the part right now, of the parts that we need right now, and write up the estimate for the customer. When I look up parts and stuff, we buy our parts from a company called Power Tool Repair. They're in Ohio, and they are a great place to purchase parts from or to send stuff in for repair. And they work on a ton of different brands. They have never let us down. Their stuff is always top-notch, great resource for us, very, very nice people to work with. So we just go to their homepage here, and you can just choose the brand, and this is an Ingersoll. So choose Ingersoll, and then you can search by your model. And it's a 2235 TiMAX. This guy right here. And then up comes the model that you're looking for. Give you a picture just to make sure it's the right one. And they give you an exploded parts diagram. How convenient is that? This is where we're going to find out everything that we need. So we know that we're going to need a screw and a gasket. Here's the gasket, which is number 14. That's right here. And number 14 over on the left tells us the availability and the price. And it says here, hammer case gasket, $1.77, out of stock. That's not a surprise. It seems like most everything is out of stock these days because of who knows why. And number 3 up here in the diagram is the screws. So we go up here for the hammer case screw. Those are $1.77. Those are in stock. So we'll put an order together. I don't know if that's $1.77 per screw or for a set, but they'll tell us. So between $1.77 for the screw and $1.77 for the gasket, the parts on this aren't going to come to much at all, $3+, and then an hour bench time, and we bill at $40 an hour, so and then there's going to be shipping on the parts and stuff. So he's probably looking at around, I'm going to say $50 to $60 to get everything fixed and back up and running. And that'll include the time that I spend on the motor, getting the gunk off of that and resurfacing that. If we needed to buy a motor, that's part number 9 here. That's the rotor up here. And we can see that the rotor is $63.38. That is the single most expensive part of the entire gun. So if he needed a new one, that's what it would cost. I don't think it's going to come to that, but we'll find out more as we explore this and try to put a new surface on that motor. I've got some steel wool here. We're going to take that to the face of the motor and see what we can do using as gentle an approach as we can first. If we have to get more aggressive with it, we can use a fine grit sandpaper, but I'd rather start as gently as possible and work our way up than go the other way and do some irreparable damage to the surface of the rotor. Now this section here has had a lot of the discoloring taken off of it. Just feeling the surface, it is pitted. So we might have to get a little more aggressive with a sandpaper or something. But we'll work the steel wool for a little while yet, see how much better we can make it, and then go with a fine sandpaper. But that does a good job of removing the rust. There's just pitting left behind. There's all the faces of the rotor having been gone over with steel wool. There's a lot of pitting and permanent discoloration. So we'll see if we can take a really fine grit sandpaper to this and get it any better, because when you have imperfect surfaces like that, it's going to create friction and it's going to prevent the tool from operating at optimal efficiency. So we'll see if we can clean that up any better. And there's also rust on the face of the rotor, so we'll see if we can get that off too. We're going to hit the rotor here with some fine grit sandpaper. I'm going to start with a 2000 grit, then we're going to move it to a 3000 grit, and then we'll polish it using a Dremel tool. And I did an experiment on one of the sections here already, and you can see how well that turned out. It's nice and shiny, all the residue is gone. It seems like that's the surface we were looking for. So I tried it out first off camera just to make sure it would work. unless I catch my screw-ups on video. Anyway, so we're going to go ahead with the rest of these sections on the rotor, and we'll also do the end here too, which seems a little rusty. We're going to start with a section of 2000 grit. There's very fine sandpaper here, and then we're going to finish the sandpaper with a 3000 grit, and then a buffing wheel on a Dremel tool. And we'll use a little oil as lubricant for the sandpaper. All the rust is gone. Most of the black marks are gone. We'll keep at it with the 2000 grit before we move on to the 3000. Although you can still see some texturing where the rust was, you really can't feel it. And even if you could, it's very minimal. So I'm confident that there will not be a performance issue with the surface the way it is right now. So we're going to go ahead and hit the other surfaces the same way we did the other two. Is it perfect? No. Is it better than it was? Oh yeah. Is it way less expensive than replacing it? You betcha. That'll be just fine. First thing when reassembling is to take the rotor, put it in the rotor housing, and make sure that the grooved end here goes out the back through the bearing. And then once that protrudes through, there's just enough room to reapply the thing. There's just enough room to reapply the snap ring. And make sure you push it down enough that it snaps back in that groove, because if it doesn't, everything's going to go back together again and you're going to have a failure and it'll be just a bad time. So make sure you double check that that's in there real good. I like to make sure I hear a positive click and then see if I can spin it around okay, see if I can pry it up out of there, and I can't. So I'm confident that it's back in there the way it should be. Your selector has an O-ring on it. Just put an application of grease around that to keep it nice and lubed, and then insert this where this tab at the bottom goes into this slot in the bottom of the motor housing. Alright, now that the rotor is back in its housing, we're going to put the vanes in here. Some people put a lot of oil in here. I don't do that. I've seen these things get jammed up over time, and sometimes the oil gets so heavy in here that the vanes don't drop out into the housing. They have to extend into the housing to catch the air in order to spin the rotor. And if there's too much oil in here, they don't do that. So be careful when you oil this. Go light. There's not a need for a lot of lubrication here because they're plastic parts against metal. So enough to keep them moving easily, but not so much that you create a problem for yourself. Just use a light tool oil. And just a few drops is all you need. It doesn't matter how you do it, as long as you get some oil in here. You can put some oil in the slots for the vanes now. You can put oil on the vanes and slide them in. I think it's gonna be cleaner and easier just to put a couple of drops in the slots for the vanes. And then each vane that goes in, notice that there's a square notch in the bottom of one side and just an angle in the bottom of the other. Square notch goes toward the front of the housing. So and the top side obviously goes against the inside surface of the housing. So this is going to follow, the bottom of the vane is going to follow the angle of the rotor and to slide it in. Now this assembly can go back in the housing. The easiest way to do it is to make sure your forward and reverse switches are in a neutral position to make sure that the air director there is in the center position, because you have to clear the bottom side of this. So that'll give you enough room just to insert that. And make sure that it pops all the way in there, like so, because you have to extend the selector out the back enough to get it to work. And your spline drive should come out to be about a 1/4 inch higher than the housing. There is a right side up and an upside down to this. The easiest way to make sure you got it right is these slots in here that are going to receive the screws from the hammer housing line up with these notches here. Two of them on top are closer than the two on the bottom. So they line up. I suggest putting this aside and then doing the whole hammer assembly next, and then mating the two assemblies. Now on this side of everything, instead of using a lighter oil, we're going to use a heavier tool grease. When you put the hammers back in the cage, these are also, there's a right side and a wrong, there's a right way and a wrong way. They look like little ghosts. Ooh, I'm the scary hammer assembly. Alright, make sure that the arms of the ghost on one are facing up and the arms of the ghost on the other are facing down. And then they go together like that. And then when they slide in, there's slots for the pins. Line up the slots and the pins just drop in. One of the pins will just drop in. There we go. Okay. Now you apply your grease on the assembly. Be careful though, because when you handle this, nothing holds those pins in, and if you pick this up, the pins are going to fall out, and then your hammers drop out, and it's a mess. So when you handle it, Just kind of tip it to the side. That way everything stays put. And again, don't go crazy with the grease, just enough to lube it up. Because what's going to happen over time is the owner should be applying grease, because there's a zerk for a grease gun. And what happens is this: they're going to apply grease and apply grease and apply grease, and they're never going to open it up and clean it out. So you're going to get a buildup of grease over time, and it's going to be too much, and then you're going to cause problems again. So I don't grease it that heavily, just enough to keep things lubricated. You want to go all on the outside of the cage too, because this whole thing spins around in there. And also the bottom side where the spline, where the splines meet between the rotor and the cage here. This all turns and spins, and there's a lot of contact areas. And then let's line up the splines, and without dropping the pins out, make sure this all mates up together like that. And then this just spins freely on the rotor. Take your anvil, put some grease on it, and you're gonna wrangle with this a little bit to get it to line up and fit, but it just slides into the hammer assembly like that. You gotta twist and turn a little bit to get the cams past everything. Gaskets next. This only goes on one way, so there's a little tab on the gasket. And by the way, this gasket, it's on back order, so I'm waiting for its replacement to come in. I'm going to reassemble this now anyway with the new screws and make sure that it works okay. If it doesn't, no big deal. We're still waiting, but at least in the meantime, I can get this back and working to the customer, and then when the new gasket comes in, I'll just pop the gasket on. There's a notch on the housing which lines up with a tab on the gasket. So when you put them on, just make sure they all line up, and that notch just sets in the gasket like that. And the two narrower holes go on the top, and the two wider holes go on the bottom. So drop the gasket on first with the tab facing up, and make sure that it lines up with the holes. And then your hammer housing goes on top of that, again making sure that all the holes line up. Now anytime you're applying bolts or screws on a part where there's gaskets involved, make sure you follow a pattern so that you're not applying all the force to one of the screws at one time and deforming your gasket. So when this goes in, we're just going to lightly get them going, and then we're going to go around a few times to tighten them sequentially. And I just got to line these up one at a time. And notice how I'm not tightening these down at all. I'm just putting them enough just to get the hole started, and then we're going to go in and do a sequential tightening. And these screws, by the way, take a T25 Torx bit. All right, so now that everything's lined up, we're going to very gently tighten these down the first time. And I got a driver here that has a clutch on it, so I can adjust this. And you want to adjust it just a little bit each time. Get a little tighter and go in a pattern that allows you to go around that gasket evenly. And a little tighter next time. Let's go test it. Check forward and reverse. Works. Check the speed settings. If I didn't have carpal tunnel syndrome, I wouldn't need a pair of pliers to it. But I can't grip anything with my fingers, so got to use a pair of pliers. There's low. Medium. High. Everything looks top notch, just like it should. So this one will go back to my customer today, as a matter of fact. I'm just banging this out in the morning before I hit the road.
You can feel that power too. That's why I didn't want any other gun other than this one.
It was as typical a repair as you'll ever see in half-inch air impact. The Ingersoll model is very popular, and they manufacture this one for other brands like Cornwell. So if you've seen one, you kind of seen them all, and this was as worry-free and trouble-free as possible, taking it apart and putting it back together again. So again, when the new gasket comes in, I'll give that to the customer, but in the meantime, it's working just fine, and he'll get some good use out of it until then. Stay tuned to the channel because we got some more air tool repair videos coming up, and we also have some other kinds of repairs that we're taking on the bench, and I figured I'd just show you the new kinds of stuff that we're taking in, like a repair to a CRKT Carson knife. And I got a great video coming up that's going to spotlight a brand new shop that just started business with some friends of mine and yours that you've known for quite a while on the channel. So do me a favor, click down here now to subscribe so that you don't miss any of it. Thank you so much for watching, and remember, use a tool. Don't be one.